Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed the discussion of textual exercise up to question number 5 for chapter number 4 from section A, Effects of Electric Current. As you know, our online assessment is going to start from the next week. So the time has come to start with the revision. So today we will start with the revision of chapter number 6, Refraction of Light. Chapter number 1 and 10 are already revised for our first online assessment. So the revision for chapter number 2, 3 and 6 are remaining. So today we start with the revision of chapter number 6. Along with it, I will just try to complete a revision of some part of chapter number 2, that is modern periodic table, about the periodic classification of elements. So let us start with the revision without wasting our time. Chapter number 6, Refraction of Light. In this chapter, those who are coming offline to the school, I had told you that on the very first page of this chapter, page number 73, out of the 3 activities, they have cancelled activity number 2 and 3. They have removed from the syllabus and only activity 1 is kept. What does this tell us? That this activity is extremely important from the examination, board examination point of view. So let us revise and let us see how it can be asked in the exam. The questions can be asked to you. Look at the activity and answer the following questions. Take a transparent glass and fill it with water. This is a transparent glass which is filled with water. Dip some portion of the pencil vertically in water and observe the thickness of the portion of pencil in water. Now keep the pencil inclined to the water surface and observe its thickness. This will be an activity in front of you. The questions they are going to ask is that what will you observe? What will you observe? Second question will be what phenomenon is it related to and define the phenomenon. What can you observe looking at the figures? That the portion of the pencil inside the water, it appears to be thicker than the portion above the water. And what do you see in the second case? That the pencil appears to be broken near the surface of water. So this will be the first part of your answer, that is your observation. Portion of the pencil inside the water appears to be thicker than the portion above water and pencil appears to be broken near the surface of water. You will get 1 mark. Now second question is what phenomenon is it related to? It is related to refraction of light. So second mark you will get over here. And define the phenomena means definition of refraction of light. Light changes its direction while going from one transparent medium to another transparent medium. This is called refraction of light. Here transparent word is very important. If transparent word is not there, half mark from the definition you are going to donate to the board. And if you don't want to make donation of marks, then small things which I tell you at every moment, you should follow the tricks, the tips. Okay. Our next very important topic for this chapter is laws of refraction. In the earlier classes, you have studied about laws of reflection. Here it is laws of refraction. Here the question can be asked, a diagram, a glass slab diagram will be placed ahead of you. Look at the diagram and identify the laws and then state the laws. It was asked in March 2020. So looking at the diagram and this diffracted ray, you will immediately tell that it is the laws of refraction. Now they have asked us state the laws. So what does your first point state? That you can see the light ray here entering from air into the glass. So here AN is your incident ray and NB is the refracted ray, because this incident ray has passed from one medium air into the other medium glass. So it has undergone refraction. So incident ray and refracted ray at the point of incidence, which is N, are on the opposite sides of the normal to the surface of the glass at that point for a given pair of media. And what you can say in the first point, you can say that the ray CD and the three, that is the incident ray, refracted ray and the normal, they all lie in the same plane. For a given pair of media, here the given pair of media is air and glass, the ratio of sin I to sin R is a constant. Here I is the angle of incidence, R is the angle of refraction, sin I upon sin R is constant, which is called as N, and N is the refractive index of second medium with respect to first medium, and this second law is also called Snell's law. Snell's law also, the question can be twisted and they can ask you about the Snell's law. After this, we are going to study two formula which are important for solving the numerical examples. Here, the velocity of light in the first medium is represented by small v1 and velocity of light in second medium is represented by v2. So when you have to mention about the refractive index of second medium with respect to the first medium, refractive index of second medium with respect to the first medium, it is equal to the ratio of velocity of light in the first medium to velocity of light in the second medium, that is v1 upon v2. In contrast, the refractive index of first medium with respect to the second medium is v2 upon v1, and if the first medium is vacuum, then the refractive index of medium 2 is called the absolute refractive index and is written as small n. Our next topic is extremely important again from board examination point of view, refraction of light in different media. I have told you that this three diagrams about the slabs will be kept ahead of you and you will be told to identify the behavior of ray of light when it moves from rarer to denser medium or when it moves from denser to rarer medium. So you should know its behavior. What happens when a ray of light, it travels from a rarer to a denser medium. Now here you can see from air to glass. This is a glass slab. So when a ray of light, it passes from a rarer to a denser medium, it bends towards the normal. Exactly opposite, when a ray of light, it travels from a denser to a rarer medium, it bends away from the normal. And in the third case, when a light ray is incident normally at the boundary between the two media, it does not change its direction and hence it does not get refracted. So this is the behavior of a ray of light and it passes through different media. Be prepared with this answer also for 3 marks in the board exam. Our next topic is about the local and that is small scale and large scale effects of atmospheric refraction. And the first is about the formation of mirage. Now if you see on page number 76, the can you tell activity they have removed out from the syllabus. So in that activity they have mentioned about mirage and all. So most probably this question won't be asked in the exam, but just for your knowledge, we will study about the small scale effects. One is the formation of mirage. What is mirage? It is the deceptive appearance of a distant object or objects which are caused by the bending of light rays. And you know that the air near the hot road or the desert area, mostly this is seen in the desert area or the hot regions. What happens? The air near the hot road or the desert surface, it is rarer than the air above it. And what happens due to it? The refractive index of air, it keeps increasing as we go to increasing heights. So the direction of light rays, they appear coming from a distance, keeping what happens, it keeps changing according to the law which we have studied, that is the laws of refraction. This light rays coming from a distant object, they appear to be coming from the image of the object inside the ground, and this is nothing but a mirage. And about the flickering of objects beyond and above a holy fire, that I have already told you, that when an holy is lightened up during on the holy day, you have seen that the direction of light rays coming from the objects beyond the holy fire changes. How they change? Due to the changing refractive index above the fire, and hence the objects appear to be flickering, they appear to be moving. Both these topics, just prepare it. I think the activity is removed, so very less chances of this part being asked in the exam. The very important part is coming ahead now, that is about the phenomena of twinkling of stars and why planets do not twinkle. And the third case is about the advanced sunrise and delayed sunset. As I have told you that from the lower classes you have studied about Twinkle Twinkle Little Star poem. But do stars actually twinkle in the sky? No, they appear to be twinkling. So very important word is stars appear twinkling in the sky. About the stars, if you know that stars are self-luminous, they have their own light and they can be seen, they are seen in the sky during the night in the absence of sunlight. They appear to be point sources because they are at a very large distance from the observer, that is from us, and as the density of air it increases with the lowering height above the surface of the earth, the refractive index it also starts increasing. So starlight, you can see in this diagram, the starlight coming towards us, towards the observer, it travels from rarer medium to denser medium and constantly it bends towards the normal. Just now we have seen about the behavior of light. When it travels from a rarer to a denser medium, it bends towards the normal, and this makes the star appear to be higher in the sky as compared to its actual position. And this apparent position of the star, it keeps changing a bit because the temperature of the air, the atmospheric conditions, density, it keeps on changing. So when the atmosphere refracts more light towards us, the star appears to be bright, and when the atmosphere refracts less light towards us, the star appears to be very dim, and hence due to the changes in refractive index of the atmosphere, stars appear to be twinkling in the sky at night. Now very important thing here is about a give reason, or secondly this diagram can be asked in the exam, not to draw, but they will draw the diagram for you, and this 4 boxes they will keep empty and they will give the names A, B, C, D or 1, 2, 3, 4, and they will tell you to label the given parts. So you should know the labels carefully: atmospheric layers, apparent position, horizon, and the real position. Now when you speak about the planets, you know that planets, they do not twinkle. Why planets do not twinkle? You know that stars and planets both are located in the sky, but as compared to the stars, planets are much closer to us, and hence they do not appear as point sources but appear as a collection of point sources. And because of the changes in the atmospheric refractive index, the position as well as the brightness of individual point source change, but the average position and the total average brightness, it remains unchanged, and hence planets do not twinkle. Average intensity, it remains the same. I have given a very good example of the students in the class. When a topic is taught to you and I tell you to prepare this topic and come the next day, it is not that each one in the class is going to come prepared. So when I ask a question on that topic, from each row, some or the other students are going to prompt the answer, making me think that the entire class knows the answer. Means average intensity will remain same because I get the answer from the entire collection from different ends. And similar is the concept with the planets. So they do not appear to be twinkling, or they do not twinkle. And the last concept I have told you about advanced sunlight and delayed sunset. that the sun should be seen by the observer when it reaches the horizon, but it is seen 2 minutes before it reaches the horizon and 2 minutes after it has set. And for this also I have taken a very good example. If a teacher is there inside the class, after the recess bell rings, all the students have entered the class. One child is late. That child wants to peep and see inside the class whether the teacher is there or no. If the child peeps and at the same time the teacher sees the child, I can see the child, but actually the child is not in that position. The child has bent. That is the same phenomena which is applied over here. What the teacher will think? The teacher will think that I can see the child from the position where he is standing, but actually the child is little bit behind. The child has bent, and this bending of light is nothing but law of refraction, and due to this refraction process, the sunrise and sunset is called as advanced sunrise and delayed sunset. Means the observer can see the sun 2 minutes before it reaches the horizon and 2 minutes after sunset. Our next very important phenomenon from this chapter, very important concept, is dispersion of light. In the topic dispersion of light, I had told you that Sir Isaac Newton, he was the first person who used a glass prism to obtain the sun's spectrum. So when a white light is incident on a prism, we had seen different colors bent through different angles. And before this phenomenon, there was a small activity which I had told you. If you just hold a plastic scale in your compass in front of your eyes and see through it while turning it slowly, you will see that the light rays are divided into 7 colors, and these colors appear in the order of Vibgyle, that is starting from violet and reaching the last color, that is R, red. Violet, indigo, blue, green, yellow, orange and red. And we have also studied from the lower standards that light is an electromagnetic radiation, and hence wavelength is an important property of radiation. The wavelength of radiation to which our human eyes are sensitive lies between the range 400 and 700 nanometers. And I had told you this was an MCQ which was asked in March 2020. The wavelength of radiation for human eyes lies between the range dash and dash, and in this interval radiation of different wavelengths appear to have different colors. The red light, it has the maximum wavelength, that is 700 nanometers, whereas the violet light has the smallest wavelength, that is about 400 nanometers. And in the experiment of Sir Isaac Newton, it was found that red color hence bends the least and violet color bends the most. Thus, as you can see in this figure, the 7 colors, they emerge along different paths, and hence we get a spectrum of 7 colors. So this 7 colors which you obtain on dispersion of light is called as spectrum. So 7 colors emerge along different paths. So we get a spectrum of 7 colors where you see that red color bends the least, whereas violet color bends the most. Here I had told you that a brief question can be asked or a diagram can be asked, and when you are told to draw a diagram related to dispersion of light, you should not use any type of colors. Instead, you have to give the names of the colors with the pencil. Our next topic, very important. So, before we go to the topic, we will just see the definition for dispersion. The process of separation of light, this white light, the sunlight, the process of separation into its component colors while passing through a medium, here glass prism is the medium, is called the dispersion of light. Our next very important topic for the board exam is partial and total internal reflection. They might give you a diagram in the exam. This diagram they won't make you draw, and based on the diagram they will ask you different questions. What is partial reflection? What is the critical angle? So what is this partial reflection? When light enters a rarer medium from a denser medium, Remember very carefully, when light enters a rarer medium from a denser medium, it gets partially reflected. That is, the part of the light gets reflected and comes back into the denser medium again as per the laws of reflection. This is called as partial reflection. You can see over here. So this can be a definition. Now the rest of the light, it gets refracted and goes into the rarer medium. Here the rarer medium is air, denser medium is water. So as the light is going from denser to the rarer medium, it bends away from the normal. You have studied about the behavior of light when the three glass slabs behavior I had shown you initially. What does this signify? That the angle of incidence I is smaller than the angle of reflection R. Now if we increase the value of I, if we increase the angle of incidence, R will also increase according to the Snell's law, as refractive index is a constant, and for a particular value of I, you are increasing the value of I, so R will also increase, and for a particular value of R, the value of R, for a particular value of I, the value of R becomes equal to 90 degree, and this value of I is called the critical angle. So they can ask, what is critical angle? And for angles of incidence larger than the critical angle, the angle of refraction is larger than 90 degree, and such rays return back into the denser medium. There is no refraction of light. All the light gets reflected back into the dense medium, and this is called as total internal reflection. They can ask in the exam, what is total internal reflection? So I hope you have understood the definitions and the likely questions which can be asked on this topic. Prepare this topic, prepare this page number 78 very thoroughly for your board exam. And the next topic also is extremely important from board examination point of view, formation of rainbow. I have told you what is rainbow. Rainbow is nothing but it is a beautiful phenomena. It is a natural phenomena which is observed in the sky after a rain shower, after rainfall. It is a combined effect of three different processes, that is dispersion, refraction and total internal reflection of light. So here small droplets, small water droplets, they behave like small glass prism. So when this light ray from the atmosphere, from the sun, it enters into these droplets, here you can see that there is a change of medium from the air to the water droplets, that is like a glass prism. So from air to water, so immediately this ray of light, it will get refracted and dispersed. Thus there is internal reflection, as you can see here in this figure, and after that once again the light gets refracted while coming out of the droplet, that is now from the denser to the rarer medium, and a combined effect of all these three processes is called as a rainbow, which can be observed in the sky after a, you can say, rainfall or rain showers. So formation of rainbow, combined effect of dispersion, refraction and total internal reflection of light. Small droplets of water act as small glass prisms. Here they can ask a direct question, explain the formation of rainbow. So when this question is asked, you have to support your answer with this diagram, or they can just provide you with this diagram and they will tell you to identify the phenomena and explain it. Then looking at the diagram, you should come to know that water droplet internal reflection means it is related to rainbow formation, and then you have to explain the topic. I hope you have understood the different topics, the different concepts. We have revised thoroughly for this chapter. So still we have some amount of time. So let us just start with a part of revision for chapter number 2, that is about the periodic classification of elements. As I have told you, why classification is required? Because today 118 elements are known to the scientific world, and around the year 1800 only about 30 elements were known. So when it comes to study about 118 elements without classification, it is very difficult. Last year 9th standard you have studied about classification of plants. This year also you have studied about classification of animals. So everywhere when you have to do a brief and informative study, their classification is a very important part, and hence different scientists came ahead with their different laws related to classification, and it was the first scientist, or you can say German scientist Doberiner, in the year 1817 he came up with his first classification known as Doberiner's triads. What he did was he made groups of three elements each having similar chemical properties, and he called them as triads. He arranged the three elements in a triad in the increasing order of their atomic mass, and he showed that the atomic mass of the middle element was approximately equal to the mean of the atomic masses of other two elements. And out of the three triads which are given in the textbook, only the first one you have to prepare, second and third they have removed out from the syllabus. Here the very important word is approximately. If approximately word is not there, because you can see looking at their mean amount, it is approximately the mean value. So that word is very important. Without this word you are going to lose half a mark in your exam. But it was found that all the elements, it did not follow Doberiner's triad. So the next scientist was an English scientist, Newland, who came up with his next classification known as Newland's law of octaves. He also correlated the atomic masses of elements to their properties, but in a different way, and in the year 1866 he arranged the elements in an increasing order of their atomic masses. So here also this classification is related to atomic masses. It started with the lightest element, hydrogen, and ended up with thorium. And what he found that every eighth element had properties similar to those of the first. For example, when he classified the elements, the first example he found that sodium is the eighth element from lithium and both have similar properties. Also magnesium shows similarity to beryllium, and chlorine, it showed similarity with fluorine. Now he compared the similarity with the octaves in music. Why octaves? Because every eighth element is showing properties similar to that of the first, and hence his law was called as law of octaves. Now as I have told you, every coin has two sides. There are some limitations to his laws also. The first limitation was this law was applicable for elements only up to calcium. When anything is introduced, when anything is discovered, it should be uniformly applicable to everyone, everything. But when it is applicable to a certain amount of elements, then surely it becomes a limitation. Next, no proper accommodation to the elements. What he did to fit all the elements, he placed two elements each in some boxes to accommodate all the known elements, and there were some elements which were placed along with the wrong elements. And last is no provision for newly discovered elements. So when elements were discovered later on, they did not find any position in his table, and that was the biggest limitation. Next was our Russian scientist Dmitry Mendeleev, who came up with his periodic table, which was also based on atomic masses. His periodic table, his law, merits, demerits, we are going to revise in our next session, that is tomorrow, along with modern periodic table. And after that we are going to revise chapter number 3, chemical reactions and equations. So I request all of you, before you attend our tomorrow's session, kindly go through the remaining topics for chapter number 2 and chapter number 3. Thank you from my side. See to it that reading of each and every chapter is going on, because if you want full marks for your exam, not only for your online assessment but even for your board exams, then reading of each and every chapter at least thrice before the board exam should be done when it comes to science and technology. That's all from my side for today. Best of luck for your preparations for your online assessment exam, and see to it that your notebooks are also completed. Thank you, dear children.